the compressibility factor for a gas under critical condition is, okay, so we have been given 4 options and we have to find the value of compressibility factor at the critical condition. Okay, and we know what is compressibility factor. Well, it is denoted by Z and is equal to PV upon RT, where P is what? P is the pressure of the gas, V is the molar volume, R is the universal gas constant, and T is the temperature of the gas. Okay, but we have to find the value of Z at critical condition. So what do we know about that? Well, at critical state, each gas has characteristic values of pressure, volume, and temperature, which is denoted by what? It is denoted by PC, VC, and TC. So PC is what? It is the critical pressure, VC is the critical volume, and TC is the critical temperature. But what do we mean by that? Well, critical temperature is the temperature above which no gas can be liquefied, right? And what is VC? Well, it is the volume of 1 mole of gas at critical temperature. And PC, that is the pressure of gas at critical temperature. Okay, so let's put these values in the formula for compressibility factor. So at critical condition, the compressibility factor, the formula would become PC VC upon RTC. Okay, now the values, these values of PC, VC and TC, you'll have to remember. Okay, you can derive them, but that is totally out of scope of the JEE syllabus that we have. Okay, so what is value of PC? PC is equal to A upon 27B square. What is VC? That is equal to 3B. And TC is equal to 8A upon 27RB. Okay, so let's put these values into the formula. Z is equal to PC VC upon RTC. That is A upon 27B square into 3B divided by that would be R into 8A by 27RB. Okay, so I'm just going to solve it here. So that becomes what? A into 3B into 27RB upon 27B square into R into 8A. Now let's solve this. So B square cancels out, 27 cancels out, R also cancels out, A also cancels out. So what do we get? We just get 3 by 8. So let's see if it matches any of our options. Well, it does. And the correct option, the correct answer to this question is option A. Let's have a look at this question. The degree of dissociation of PCl5 at a certain temperature and 1 atmosphere pressure is 0.2. Calculate the value of equilibrium constant Kp. Okay, so what is the reaction? Well, PCl5 dissociates to give PCl3 plus Cl2. Okay, what would be the Kp for this reaction? Well, Kp, do you remember? You remember what Kp is? Kp is the product of partial pressures of the products raised to the power their stoichiometric coefficients divided by the product of partial pressures of the reactants raised to the power their stoichiometric coefficients. Okay, so it will be equal to what? Partial pressure of PCl3 multiplied by the partial pressure of Cl2 divided by the partial pressure of PCl5. Always remember that these partial pressures are at what? Are at equilibrium. Okay. And what is partial pressure of PCl3? Well, that would be equal to mole fraction of PCl3 multiplied by the total pressure. Okay. And we have been given what? We have been given the total pressure. But we do not know about the mole fraction or the number of moles of the reactants and products at equilibrium. And that is what we have to find out. Okay, so let's write the equation again. This would be a reversible reaction, okay, not the irreversible reaction. Okay, so PCl5 dissociates to give what? PCl3 plus Cl2. Okay, So now, if at T is equal to 0, that is when the reaction has not started. Okay, if we assume that we have 1 mole of PCl5 and we have 0 moles of PCl3 and Cl2. Okay, at T is equal to T equilibrium, what is going to happen? Well, a fraction of that 1 mole of PCl5 is going to dissociate into PCl3 and Cl2. So, how would we write it as? We write it as 1 minus alpha would be the number of moles of PCl5 at equilibrium, and alpha would be the number of moles of PCl3 and Cl2 at equilibrium. How did we get this? Okay, let's see here. So if it would have been an irreversible reaction, so PCl5 would have dissociated into what? PCl2 and Cl2. Right. So that would mean what? 1 mole of PCl5 would completely dissociate into 1 mole of PCl3. Sorry, this would be PCl3. Into PCl3 and 1 mole of Cl2. Right. However, this is the reaction that we have is not an irreversible reaction. It is a reversible reaction. Okay. But so that what does that mean? That means the complete dissociation is not going to happen, right? The reaction is not going to proceed to like complete its 100% reaction. However, a fraction of number of moles, a fraction of PCl5 is going to dissociate. Okay. So if that fraction is alpha, then PCl3 and Cl2 will also be what? Alpha formed at equilibrium. Okay. So if now we have got what? We have got the number of moles of the products and reactants. We have got the number of moles of products and reactants at equilibrium. Okay. So what are the total number of moles at equilibrium? So what are the total number of moles? That will be equal to what? 1 minus alpha plus alpha plus alpha. That is equal to 1 plus alpha. Okay. Now, we can easily find all our mole fractions of products and reactants. So, what will be the mole fraction of PCl3? That will be equal to what? Alpha upon 1 plus alpha. Right. What would be the mole fraction of Cl2? Same. It would be alpha upon 1 plus alpha. And what would be the mole fraction of PCl5? That would be 1 minus alpha upon 1 plus alpha. Okay, so these are the mole fractions at what? These are the mole fractions at equilibrium. Okay, so now we know Kp is what? It is partial pressure of PCl3 multiply partial pressure of Cl2 divided by partial pressure of PCl5. What is partial pressure of PCl3? That is mole fraction of PCl3, and that would be mole fraction of PCl3 into total pressure. Okay, so mole fraction of PCl3 is what? Alpha upon 1 plus alpha, and total pressure, right? What is the partial pressure of Cl2? That is mole fraction of Cl2, that is alpha upon 1 plus alpha into total pressure. And what is partial pressure of PCl5? That would be mole fraction of PCl5, 1 minus alpha upon 1 plus alpha into total pressure. Okay, let's simplify this equation that we have found, that we have, come to. Okay, so this will be alpha into alpha upon 1 plus alpha into 1 plus alpha into 1 minus alpha into 1 plus alpha, right? And into total pressure. Okay, 1 plus alpha cancels out. And what is this? What do we know? We know that a square minus b square is equal to what? A minus b into a plus b. So we'll substitute this formula here. So what we'll get? Alpha square upon 1 square minus alpha square into Pt. Pt is what? The total pressure. Okay. So what we have been given? We have been given the value of alpha. We also have been given the value of pressure, total pressure. So let's put these value into this equation that we have got and we'll get our answer. So alpha is 0.2. 0.2 square upon 1 minus 0.2 square into total pressure is 1. So this would be 0.04 upon 1 minus 0.04. So that would be what? 0.04 divided by 0.96. That is 4 by 96, right? So, okay, so let's see, what do we get? 1, 4 2s are 8, 4. So that is 1 divided by 24. Let's do the calculation here. So 24, that would be 24, 4. 4 4s are 16, 1, 96. So 4, so we get total, the value we get would be close to 0.04. Let's see if it matches any of our option. Well, it does, and the answer to this question is option B. Let's have a look at this question. Which will make basic buffer? Okay, so we have been given 4 options, 4 reactions, right? 4 set of reactions, and we have to tell the option, the correct option in which we are getting basic buffer in the end of the reaction, right? But what is a basic buffer? Well, basic buffer is a combination of weak base and its conjugate acid. Okay, and its conjugate acid. So what do we mean by base? Well, base is a substance which dissociates into OH minus ions, which dissociates and gives OH minus ions in aqueous solution. So what do we mean by that? Let's see. So if we have BOH and it dissociates to give what? B plus and OH minus ions in the aqueous solution, right? So hence we call BOH a base. Okay, but what is a weak base? And do we have a strong base as well? Well, yes, we do. Right now, the equation in front of you, right? This is an equation of strong base. Why? Well, this is an irreversible reaction and all of the base is dissociating into B plus and OH minus in the aqueous solution, right? So that's why this reaction is what? A strong base, a reaction of a strong base. But what is a weak base? Well, if it would have been a reversible reaction, right, then the complete dissociation would not happen. There might be 10% dissociation, 20%, 50%, 70%, but 100% dissociation of the base will not take place. Hence, we call this base, this equation right now in front of us is what? An equation of weak base, right? But what is conjugate acid? Well, whenever a base dissociates into ions and gives OH minus, right? So the other part, the positive part, right? The positive, the cation that we got after the dissociation of the base, that is what? That is conjugate acid. Okay. Now, after all this information, let's check all the options one by one. So in the first option, we have the reaction of NaOH plus CH3COH. So they'll react to give what? CH3COONA plus water. Okay. And how much of NaOH and CH3COH do we have? Well, we are given 0.1 molar NaOH, 0.1 molar CH3COH, 20, this is 50 ml NaOH and 25 ml NaOH. Okay, so looking at the equation, so this is a balanced equation. So we can say that 1 mole of NaOH requires what? 1 mole of CH3COH to react, right? So let's find how many millimoles of NaOH and CH3COH do we have here. So that will be what? That will be molarity multiplied by the volume, right? So here we get 5 millimoles and here we get 2.5 millimoles. Since they have to react in 1:1 molar ratio, right? So what would happen after the reaction? We'll have 2.5 millimoles of NaOH in the solution, and there will be complete utilization of CH3COH, and we'll have 2.5 millimoles of what? CH3CO Na in the solution, and we'll also have 2.5 millimoles of water, right? So this is actually a basic solution. Why? Because we have a strong base in the solution after the reaction. However, this is not the basic buffer. Why? Because we wanted a combination of what? We wanted a combination of weak base and its conjugate acid, right? And so this is weak base and conjugate acid, which is not the case in the first option. So the first option is not correct, right? So let's move on to the second option, which is also the reaction of NaOH plus CH3COH giving CH3COONA plus water. Okay, and what is the molarity and volume of CH3COH and NaOH given to us? So for both, it is 0.1 molar, and for both, it is 100 ml. Okay. So we have already established that what they NaOH and CH3COH, they react in 1:1 ratio. Okay. So how many millimoles of NaOH do we have? Well, we have 10 millimoles. What we did, we multiplied molarity by volume, right? And here CH3COH is also for CH3COH, we also have 10 millimoles. So after the reaction, what is going to happen? We'll have 0 moles of NaOH and 0 moles of CH3COH, but we'll have 10 moles of the salt and 10 moles of water, right? So this also is not the case of basic buffer. Why? Because we do not have the combination of weak base and its conjugate acid, right? So we do not have this. So this is not the correct option, right? But what exactly is happening here? Let's see. So we have CH3CO minus Na plus, right? And we have water in the system also, right? So that is, so the salt actually reacts with water to give CH3COH plus Na plus OH minus. Okay. So here what has happened, CH3CO minus, right? That has abstracted H plus from water to form what? Acetic acid. But same has not happened for Na plus. Na plus has not abstracted OH minus from water to give NaOH. Why? Well, always remember that the conjugate acid or conjugate base of a strong acid or a strong base is never going to get hydrolyzed by water. Okay, never. Why? Well, let's say for an instance, if Na plus would have reacted with OH minus to give what? NaOH, right? But we know NaOH is what? NaOH is a strong base. What happens to a strong base? A strong base dissociates, and it is an irreversible reaction. It dissociates into Na plus and OH minus in the aqueous solution, right? So if it is an irreversible reaction, that means Na plus and OH minus can never join together or can never combine to form NaOH. That's why the salt hydrolysis of conjugate acid or conjugate base of a strong acid or strong base never takes place. Okay, so even our option B is not correct. So let's move on to option C. So here we have HCl reacting with NaOH. No, that is not NaOH, that is NH4OH. So this is what? This is a combination of strong acid and a weak base. So they will react to give salt, that is NH4Cl plus water. Okay, so HCl, how much HCl molarity and volume is given to us? It's 0.1 molar and 100 ml. And what is the molarity and volume of NH4OH given to us? That is 0.1 molar, 200 ml. Okay, so they are also reacting in 1:1 ratio. So let's calculate the number of millimoles of both HCl and NH4OH. Okay, so that would be 0.1 into 100, that is 10 millimoles. And this is 0.1 into 200, that is 20 millimoles, right? So after the reaction, what would happen? So 10 millimoles of HCl is totally going to get consumed up. right? So 10 millimoles of HCl will react with 10 millimoles of NH4OH. So 10 millimoles of NH4OH will be left after the reaction, and we'll get what? 10 millimoles of NH4Cl and 10 millimoles of water as well. Okay. So what do we have here after the reaction? We have weak base, correct? Because NH4OH is a weak base. And do we have its conjugate base as well? Well, let's see how does NH4OH dissociates, right? So NH4OH will dissociate to give what? NH4 plus OH minus. So the conjugate acid for NH4 plus for NH4OH is NH4 plus, right? So what do we have? We have weak base also. We have 10 millimoles of weak base. And we have what? We have 10 millimoles of conjugate acid as well. Why? Well, NH4Cl will exist as what? NH4 plus Cl minus, because it's a salt. So it's going to exist as what? Cation and anion in the aqueous solution. So we also have 10 millimoles of NH4 plus, which is our conjugate acid. So this is the combination that we were looking for, and yes, this is our correct option. But however, let's look at it. Have a look at the fourth option as well. Okay. So what does fourth option says? Just a second, I'm just finding the correct slide to put it at. Okay, so the fourth option is the reaction of what? HCl and NaOH. Right? And we have been given what? 0.1 molar HCl, 0.1 molar NaOH, and 100 ml of both. Right? And this is a very easy reaction. We know that HCl and NaOH are both strong acid and strong base, respectively. So what do we get? We get NaCl plus water. Right? So let's see how many millimoles of HCl do we have? We have 10 millimoles. Why? Because we multiplied 0.1 into 100. That is molarity into volume. And for NaOH also we have 10 millimoles. So after the reaction, what is going to happen? We'll have 0 millimoles of HCl, 0 millimoles of NaOH, and we'll have 10 millimoles of NaCl and 10 millimoles of water. Right? So this is what? This is a neutralization reaction. Right? The complete neutralization is going to happen for between H plus and OH minus ions. So we are going to get what? We are going to get a neutral solution. Would salt hydrolysis happen here? Well, no. Why? Because Na plus is what? Na plus is the conjugate acid of a strong base, that is NaOH. And what is Cl minus? Cl minus is the conjugate base of a strong acid, that is HCl. Right? So the salt hydrolysis of NaCl is not going to take place. Right? So we have already found out what? That the correct option to our question is option C. Let's have a look at this question. Give the atomic number of the inert gas atom in which the total number of d electrons is equal to the difference in the number of total p and s electrons. Okay, this is a very easy question if you know the periodic table little bit also. Okay, so what do we know about the periodic table? So we have 18th group here, right? Let's draw the 18th group. Okay. So what is the first inert gas we have? That is helium, right? That is the first period. In the first period. In the second period, what we have? We have neon. In the third period, we have krypton. Sorry, that is argon. In the third period, we have argon. In the fourth period, we have krypton. And in the fifth period, we have xenon. Okay. So we know that the first three periods, right? For the first three periods, the d electrons are not filled. Why? Let's look at the electronic configuration, okay, or the atomic numbers actually. So helium has atomic number of 2. Neon has what? 2 plus 8, that is 10. Argon would have 10 plus 8, that would be 18, right? Krypton would have 18 plus 18, that is 36. And xenon will have 36 plus 18, that is 54. Okay, so up till argon, no atom has filled d electrons up till argon. Okay, so let's check it out. What happens in the case of krypton? Okay, so what is the electronic configuration of krypton? We have atomic number as what? 36. So that would be 1s2, 2s2, 2p6. I hope you remember how I am filling these electrons, like how I am writing this electronic configuration, the Aufbau principle, right? I hope you remember that. So 1s2, 2s2, 2p6, 3s2, 3p6. Next would be 4s2. 4s2, 3d10. Let's see how many electrons we have filled up till now. So 2 plus 2, 4, 6, 10, 2, 12, 6, 18, 2, 20, 10, 30. So we have filled 30 electrons up till now. So this would be what? 4p6. Okay. So these are total 36 electrons. How many d electrons do we have? That is 10. How many s electrons do we have? So 2 plus 2, 4, plus 2, 6, plus 2, 8. So we have 8 s electrons. And how many p electrons do we have? That is 6 plus 6, 12, plus 6, 18. Okay, what do we need to find? We need to find the atomic number of the inert gas in which the d electrons is equal to the difference in the number of p and s electrons. Okay, so what do we have to find? We have to find the difference between the number of electrons of p orbital and s orbital. So that is what? 18 minus 8, that is 10, and it is equal to the number of d electrons in krypton with atomic number what? 36, and it matches option A. So the correct option to this question is option A. Let's have a look at this question. De-broglie wavelength of an electron traveling with speed equal to 1% of speed of light is. Okay, so what do we have to find? We have to find the de-broglie wavelength of an electron. So what is de-broglie wavelength? It is equal to what? H upon mv. Right? It's very easy. So H is what? H is the Planck's constant, which is equal to 6.626 into 10 to the power minus 34 joule second. And what is m? M is the mass of electron, 9.1 into 10 to the power minus 31 kg. And what is v? Well, velocity of the electron, and it is given as 1% of speed of light. Speed of light is what? 3 into 10 to the power 8 meter per second. So let's calculate the velocity. That would be 1 upon 100 into 3 into 10 to the power 8. So it comes out to be what? 3 into 10 to the power 6 meter per second. So what do we have to do now? We have all the values, and we'll just put it into the formula. So lambda will be equal to what? 6.6. Let's approximate 6.626 as 6.6 for easy calculation. Okay. So 6.6 into 10 to the power minus 34 upon 9.1 into 10 to the power minus 31 into 3 into 10 to the power 6. Okay. So this will be 6.6 upon 9.1 into 3 into 10 to the power minus 34 plus 31 minus 6. Okay, let's see what do we get. So this is 6.6 upon 9.1 into 3 into 10 to the power minus 31 plus 30. No, this is minus 34 plus 31 minus 6. Okay. So this will be 2.2. So what do we have to calculate? We have to divide 22 by 91. And this is 10 to the power minus 34 plus 31 would be minus 3. And minus 3 minus 6 would be minus 9. Okay. So 22 divided by 91. We'll put a decimal, so 220. Right. So 91. So instead of dividing 220 by 91, let's make it as 9. Okay. So instead of 9.1, I'm approximating it as 9. So this will come as 22 divided by 90. So we'll divide 22 by 9. So 9 2s are 18. We have 4 point, we'll add the decimal 40. So 9 4s are 36, 44. Cool. So the value we are getting is approximately what 2.44 divided by 10 into 10 to the power minus 9. Okay. So can we say this is 0.244 into 10 to the power minus 9, right? Minus 9 meter. So let's see the options. Okay, so options given to us are in picometers. So let's convert this meter into picometer, which is very easy. How? So we have to convert this 10 to the power minus 9 into 10 to the power minus 12. So 10 to the power minus 9 is what? Nanometer. So right now what we have calculated is 0.244 nanometer. Okay. But the options given to us are in picometers. So we'll convert 10 to the power minus 9 into 10 to the power minus 12. How can we do that? So it is 0.244 into 10 to the power minus 9. So to convert 10 to the power minus 9 to 10 to the power minus 12, what we'll do? We'll multiply it by 10 to the power minus 3. Since we have multiplied it by 10 to the power minus 3, we will also have to multiply it by 10 to the power 3. Seems like a tongue twister, very difficult one to speak. Okay, so this will be what? This will be 10 to the power minus 12. And here we have to multiply 2.244 into 10 to the power 3. So that would be 244 into 10 to the power minus 12, right? So remember, this is an approximate value because we changed the denominator. Always remember that when you're changing the numerator, the difference is not that much. But however, if you're changing the denominator, there might be some difference, okay? Always keep that in mind. So here we get it as 244 picometers. Let's see which option is very, very close to our answer that we have got. Well, option C, that is very, very close to the answer that we got after calculating, and option C is the correct option.